Hello and welcome to another video. This one was actually a question sent in by my friend JR, who asked about the specifics of self-type in a particular case, and we will jump into it. But before that, I did another video on typing self, so I'm going to briefly go over the details here, but if you want a more thorough picture, this video has a lot more things there. Okay, so the idea behind self is, well, at least in most cases that I've used it, it is a way for a class to refer to itself and perhaps whatever subclass that may be implemented in the future. I've almost always used it as a way to have alternative constructors via class methods or for cloning methods. Things that take an instance and return a brand new instance that's the same as the existing one, but a copy. But self is actually allowed in other positions in classes. For instance, it can annotate a parameter, which is done here. This particular class method is sort of interesting. It's an identity function, so it's not that interesting. But I think it's interesting in that it has self as a parameter position and a return value. It also enforces that anything that is passed into this has to match whatever class that you're trying to access it on. So if you did foo.identity and then some other non-foo class, you would get a type error and the type checker runs. If you did it the other way around, so some subclass of foo, like foo2, which doesn't exist here, and you passed in a foo as this object here, you would also get a type error. So it has to exactly match the class in the call. I guess we should set up Mypy and run the rest of these, but JR notes that this particular line fails, and JR is surprised by this, and this line down here succeeds, which also seems surprising because it is very similar to the line that's here. We'll outline the differences and then explain why this one works, but this one does not. So let's install a type checker just to show you those failures. Pip install Mypy. And my example is slightly different than JR's because I wanted to fit on one screen, but yeah, anyway. Okay, so if we look at this, Mypy gives us an error. Argument 1 to identity of foo has incompatible type foo, which sounds silly for starters. And it says expected self. Okay, interesting. Yeah, that's true. Now, the reason for this is, or the shortest explanation for this is, self needs to work for every subclass that's possible of foo. So if we had, for instance, a class foo2, which is just a simple subclass of foo, and you somehow called this use identity function, foo2.use identity, you would expect this x variable to have the type foo2 as it is annotated self. However, you'll notice that we are getting a foo instance here, base class, and passing that through the identity function, and so we'll get the base class back out. And so we sort of have a slicing, as it's called in object-oriented programming, where you accidentally return a base class instance when you would have wanted a subclass. And so this is the reason that the type checker rejects this particular thing here. The kind of idea of self, especially as a return type, I mean, this one is kind of a special case because it's just a identity passer, but self in a return type, the type checker enforces that everything that gets returned from this is either derived from, well, you can imagine there is an implicit type self here, and there's an implicit, well, we don't have any methods, but say we had a method here. There's an implicit self here as well. So the type checker is kind of, it'd be really annoying to have to type this everywhere. So this is implicit. So what the type checker does is it enforces that your return value must be derived from this in some way. So it must somehow be a call to class or a call to, let's say this also, this is a clone method. Self. It must be somehow type self all as the return value. And the type checker enforces this such that this annotation is satisfied. Anything else is illegal, essentially. I mean, obviously we see another case here where you have a parameter. There's cases where it takes in the actual self object. But if you're just returning a value, it must be self. It must be derived from the type of whatever the first parameter is, so that you actually preserve the classes correctly. So if we were to change this function here to instead be CLS, Now this is always going to construct a foo2 here, and we'll get a foo2 out. So this satisfies the self. So that's kind of the reason here, subclassing. These annotations may be possibly correct if you could forbid subclassing of this, which there's typing.Final, which can help you with that, although never used it. Probably because I don't really use object-oriented programming all that much, but typing.Final would prevent you from subclassing this, and then the annotation would be air quotes correct, but at that point you wouldn't use self, you would just use foo, so there would be no point in using self, so yeah, it's a little tricky like that. Oh, I guess I should talk about why did this one down here succeed. So in this case, get foo returns a foo. We're calling foo.identity, so foo matches foo, and so there's no type mismatch here at all. Whereas here, self had to refer to whatever potential subclass of foo existed. So that's why this one was successful. Yeah, so the big, like, the main takeaway from this is self refers to whatever the current subclass is. You can think of it as a type variable that is bound to base class, and so it will always refer to whatever the most specific type is, and so it has to be generic return value. Hopefully you found this useful. If there are additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.